The purpose of this project is to design a small version of cardboard shredder for home use with similar function of a paper shredder, but with an affordable price. This cardboard shredder will reduce the occupying space of cardboard into compacted recycling waste. This shredded cardboard product will take up less space and can be manipulated more easily than the rigid cardboard box. Once shredded and compacted, the user can then insert into their recycling bin and ultimately maximize the given volume. The user will also save their time on eliminating clutters and fire hazards around their house. They also contribute to a sustainable environment by shredding and recycling cardboard.
To explain the working principles of the cardboard shredder, there's one crank which replaces the motor used to power the mechanism. The crank rotates and drives a set of two identical external spur gears and two shafts. The shaft parts are attached to multiple blades that move in the opposite directions to pull the cardboard downward and simultaneously shred it into small pieces. The shear force acts on the cardboard comes from the strain of the blade's teeth and torque generated from the crank and gear set. The whole mechanism is put inside the machine, and it is supported by flanks, bones, and a machine frame. Additionally, the box below serves as a storage for recycling cardboard waste.
For the stress analysis, we used a simulation add-in by SolidWorks. The applied force would be 25 pounds at the handle of the crank, which we would then calculate the proper forces for each individual component. Running analysis on individual components allows us to see which part is likely to fail and design accordingly. The overall analysis was a success, proving to have a safety factor of well over 10 on the shaft, gear, blade, and rotating assembly. This means the assembly can handle a much larger load and various materials. The motion study was also done in SolidWorks, in which we animated the rotating assembly and the exploded construction of the entire cardboard shredder.
In conclusion, we were able to design a functioning compact cardboard shredder for home use, which reduces the space taken up by cardboard boxes through shredding into smaller, more easily manipulated pieces of cardboard. The design features a manually operated crank that drives a rotating shaft and blade system to shred the cardboard. The assembly was found to have a safety factor of over 10 based on the stress analysis with the selected materials and applied loads. Overall, the cardboard shredder has been designed to be compact, functional, and reliable.